welcome everyone. We have seen what is mixture. The two types of mixture are homogeneous mixture and heterogeneous mixture. Further classified into solution, also known as true solution, colloidal and suspension. We have already finished solution, so today we are going to discuss suspension. Suspension is a heterogeneous mixture which contains small insoluble particles of solute spread throughout the solution or throughout the solvent without getting dissolved. Some examples are chalk and water solution, mud and water solution, smoke coming out of chimneys or automobiles. Let's quickly see what are the properties of suspension. First, suspension is heterogeneous in nature. The second, the diameter of the solute particles are greater than 10 to the power minus 6 meter. The particle size is so big that they don't pass through the filter paper. Then the appearance of suspension solution is from hazy to opaque. The transparent of light is not transparency is not there in the solution. Next, when the suspension solution is left for some time, the higher particles will settle down. The particles settle down under gravity and lighter particles will be floating in the solution, and very fine particles remain suspended in the solution. So these, and yes, one more very important property of suspension is they scatter the beam of light and the path of the light is visible in suspension solution. So these are the few properties of suspension. Now we will see what are colloidal solution. So colloidal, it appears like homogeneous but it is heterogeneous in nature. The mixture in which the diameter of the solute is intermediate between the true solution and suspension is called colloidal solution. Means here in colloidal, the diameter of the particle size will lie between 10 to the power minus 9 to 10 to the power minus 6 meter. So this is the particle size. Like we have seen in solution, the two components in solution are solute and solvent. Similarly, in colloidal solution also, there are two phases. This colloidal solution are also known as sols. Okay, colloidal solution is also known as sols. Okay, I'll just tell the names. The colloidal solution are also known as sols. The colloidal solution in water are called hydrosols, this is hydrosols, the colloidal solution in water. The colloidal solution in benzene are called benzosols, and the colloidal solution in air are called aerosols. So that anytime when you come across these words, you could make out what are these. This hydrosol is the colloidal solution in water. Benzosols are the colloidal solution in benzene, and aerosols are the colloidal solution in air. Now, this colloidal solution consists of two phases. Now we will discuss about colloidal solution. Colloidal solution consists of two phases. One is dispersed phase, and second is dispersion medium. So colloidal solution consists of two phases. One is dispersed phase and second is dispersion medium. Now we will see what is dispersed phase. The component of the colloidal solution which is found in very less quantity. Just I'll write it down. The component of colloidal solution present in smaller proportion and consists of particle dimension 10 to power minus 9 to 10 to power minus 6 meter are called dispersed phase. The component of colloidal solution present in smaller proportion and consists of particle dimension 10 to power minus 9 to 10 to power minus 6 meter are dispersed medium. Whereas the component of colloidal solution which is in excess and acts as a medium to acts as a medium in which solute is dispersed is called dispersion medium. Yes. So what is dispersion medium? The component of colloidal solution which is in excess and acts as a medium in which solute is dispersed throughout is called dispersion medium. So these are the few things about colloidal solution. Now, depending upon the physical state of dispersed phase and dispersing medium, colloidal solution are classified into various types. Let's see what are those. This column is dispersed phase, this is dispersing medium, types and examples. In this, dispersing medium is in more quantity, whereas dispersed phase is in very small quantity, small proportion. So, liquid and gas. The type is aerosol. Examples: fog, cloud, mist. Mist means tiny droplets of water in the atmosphere, in air. Next is solid and gas, is called aerosol. Examples are smoke, automobile, exhaust. Next one is gas and liquid, is in the form of a foam, like shaving cream. When the shaving cream is like a paste only, but when we mix it, then it comes in a form of foam. Liquid and liquid is emulsion. Like when we are mixing any liquid thing like oil with like anything, any liquid, so it becomes emulsion. Oil and vinegar or like that. Like milk and face cream. In face cream, what you will see, moisture will be more in face cream. Okay, so when liquid and liquid are mixed, face cream is a very good example. Solid liquid is called salt, like milk of magnesia or mud. Gas and liquid. Here again foam, because the quantity of liquid is more whereas the quantity of gas is less. So in the form of foam, rubber or sponge. Sponge, because when you take a sponge, in sponge it is a solid but it's very porous. So air is trapped in that. So we can, sponge is a very good example. Now liquid, solid, gel, like examples are jelly, cheese, butter. Solid is solid salt. Solid salt, it can be colored gem or milky glass. So these are the few types of colloids. Now quickly we will see the properties of colloids. Colloidal solution. First is colloidal are heterogeneous in nature. Second, the particles of the solute is intermediate between the solution and a suspension. They are so small that they can easily pass through a filter paper. The solution easily pass through a filter paper. The particles of the solute in colloidal solution is so small that it cannot be seen to the naked eyes, but it can be seen through a powerful microscope. Then next you can take as Brownian movement. I want to introduce this term to you. The colloidal particles seem to move randomly in a zigzag motion in all the directions when seen under a microscope. It was first observed by Robert Brown. So, it is Brownian movement. In this, what happens? The colloidal particles are hit by the hit in the dispersion medium in all the directions and in with different forces. So this is Brownian movement is seen in colloidal solution. Now the next property is optical property. What is optical property? When a beam of light is passed through a colloidal solution, the beam of light scatters. Okay, the beam of light scatters and the path of the light is visible. Nicely, it is visible through the colloidal solution. This phenomenon of scattering of light, as a result the path of the beam of light is visible is called Tyndall effect. Is called Tyndall effect. So I'll write the word here. Is called Tyndall effect. Is it clear, children? The phenomenon, we can write the phenomenon. The phenomenon of scattering of light, as a result the path of the beam of light is visible, is called Tyndall effect. So this is a very important property in colloidal solution. Tyndall effect is also observed when a fine beam of light enters the room through a small hole. It is also observed when a beam of light passes through a canopy of a dense forest. This is due to the scattering of the light in the colloidal particle of mist. Mist means tiny droplets of water in the air. So when it passes through, because of the tiny particles, the beam of light strikes and it scatters the light, and so it can be seen in the dense forest. So these are the few properties of colloidal solution.